Hello students, let's start off with definite integration and let's start off with its introduction, which is actually the limit as a sum method. And people who know integration well now can relate to definite integration. The only difference you can find now is that there are limits. So this is the lower limit and this is the upper limit. And this is the same integration thing which we will be using. So let's see what different it is and how we can, do the sum. So let's start off with this. So first, let's start off with the basic introduction of this, that how definite integration is used and what is the concept behind it. So let's just make x and y axis. So let's draw this. So let's say this is your y axis, the x axis. Okay, let's make a curve. So let's make a curve like this. Okay, and this is the point. Let's say this is a and this is on x, so this is x equal to a and this is a point and this is x equal to b. Okay, and what you have to do is you have to find the area under this curve. Now obviously this is not a regular figure wherein you can just use a formula and get the area. So this is a irregular curve, right? So what is the concept which we'll be using is, under this curve I'll be making rectangles. So let's say I make this one rectangle and I'll make big rectangles just to make you understand. So I'll make one rectangle. Now what I'll do is, similarly with this rectangle, let's say the width of this rectangle is h. Okay. Now what I'll do is, such rectangles, I'll make a lot of rectangles, okay, which has the same width h. Obviously the height is not same, right? Now what I'm doing is I'll be finding the area of this rectangle, one more rectangle, and as many as I can get, and I will add all the areas. Okay, and that will give me the area under this curve. So what I'll do is, this is a, and this point now, this point would be a plus h. So obviously the height of this will be, because this curve is y is equal to fx, so height of this one will be f of a plus h. Similarly, the height of the other rectangle I'll take as, now this will be h plus h. So this height will be f of a plus 2h. Similarly, we'll keep going and till the last when we reach here, since we'll have a lot of rectangles, n rectangles, the last height would be a plus nh. And I'll be finding all the areas of all the rectangles. Now the thing is, let's just write that formula. So let's say I write the formula as, so since I'll be finding the area of rectangle, I'll be writing the width is h and the height. So I'll write width as h, height as f of a plus, let's define a variable r, rh, where r will go from, because I have to sum this, so I'll write r goes from 1 to n. So what will happen is, this is the summation sign. So when you put r as 1, you'll get h into f of a plus h. Then you'll put r as 2, you'll get h into f of a plus 2h, and you'll add all these areas, right? Now the thing is, if you realize that if you find the area of this rectangle, see, there will be some error which will be left. See, this is not an exact rectangle, right? So in this case, what we'll do is, since in all the rectangles you'll have some error, so what you'll do is you will make infinite rectangles. Infinite means that you will try to accommodate as many rectangles as possible in this. So with this, what will happen is that the error would be negligible. So what I'm saying is, what we'll do is, I will write limit. Why I'm using limit? Because n is the number of rectangles and n has to be very large. So I'll write n tends to infinity, right? When n is tending towards infinity, that means we have infinite rectangles, and this will then give you the area under this curve. So if you realize, this part is a, this part is b, this part is a, and this length will be b minus a, and if I divide this length by the n rectangles, I'll get the height, the width of each rectangle, which is h, right? And this actually the long cut of definite integration. So if you remember this formula, so let's take a simple example. Let's say I need to find the area under the curve. So they say that let's find the area under the curve for, let's say the function is fx is equal to 2x plus 5. Okay, so what I'll do is, and let's see the limit you have been given is 1 to 2. Okay, so actually what they are asking you to find, they are asking you to find 1 to 2 integration of 2x plus 5 dx. Okay, now what I'll do is I'll first try to find this using the area under the curve method, the limit as a sum. So they have given this as, so this as 1, the lower limit. So I'll take this as a, upper limit b, function they have given, and the formula we know. The formula is limit n tending towards infinity, summation r goes from 1 to n h into f of a plus rh. This is the formula, right? Now we also know b minus a upon n is equal to h. Now b minus a we know it's 2 minus 1 upon n equal to h. So n into h will give you 1. So I got the value of n of h, nh. Okay. Now let's start off this question. So what we'll do is first we'll put the values. We'll write limit n tending towards infinity, summation r 1 to n. Now h into f of a plus rh, right? Now h f of a plus rh, that means wherever you have x you will put a plus rh, and a we know a is 1. So what I'll do is the function, in the function x, in x will write a plus rh, that is 1 plus rh plus 5. Let's solve this. We get limit n tends to infinity, summation r equal to 1 to n h. Now we'll multiply this. You have, so you have 2 plus 2rh plus 5. This gives you limit n tends to infinity, summation r goes from 1 to n, and you get 2h plus 2rh plus all right, 5h. So actually I can just make this as, I can just make this as 7h. Okay, now we have to use the summation sign, and in fact this one thing we have to remember here, this h when it gets multiplied here, so this will be h square. Okay, now we take the summation inside. So when we take the summation inside, we get limit n tending towards infinity and summation of h. Now see, the variable is r, the operator is r, and this is h. So that means we are taking summation of 1, and summation of 1 will be n, right? Because h is not the operator, r is the operator. So 7h into 1, summation of 1 is n, plus here r is there, so we have 2 h square, and here we have r. So summation of r is, we'll use the formula n into n plus 1 by 2. So summation is gone. Now we just have to use the limit, and before we do that, I see that we have limit n tending towards infinity. nh, we know the value of nh at the start we had found, that is 1 plus 2 h square. Now I'll take this n out. I'll take this n out. So what I'll get is h square n square 1 plus 1 by n upon 2. This 2 gets cancelled. nh square. So nh square is again 1. So what you get, limit. Now let's apply this limit n tending towards infinity. So this will be 7 plus, and see 1 upon n. So n is infinity. So this will be 0. So you get 7 plus 1, which is equal to 8. So area under the curve is 8. So this is what we got using this method. This method is called limit as a sum. So the question was this, we had to find the integration of this, and we found using limit as a sum. So actually definite integration is area under the curve, and we will never use this method. This is only used for understanding. The method which we'll use, by will by which we'll get the answer in just 2 steps. So we have integration 1 to 2, 2x plus 5. So in definite integration, we just need to remember all the formulas of integration, and 2x, so we know the formula for 2x, so 2x x square by 2 plus 5 integration is 5x. Okay, and let's say you put the constant, let's say you put the constant c, and you have 1 to 2. These are the limits. Now the method is, you will first put the upper limit, so upper limit is 2, so 2 square plus 5 into 2 plus c, minus you put the lower limit, that is 1 square plus 5 plus c, and you realize that c gets cancelled, and what is left is the answer, that is 4 plus 10 minus 1 plus 5, that is 6, which is 8. So that means in definite integration you don't have c, the concept of integration will be missing. Why? Because it actually gets cancelled, so you don't need to write this, and what you got is the same answer which we got here using the long cut. So definite integration is actually area under the curve, and that's the reason it's also used in physics, especially in kinematical equations. To derive those equations, we use integration. So hope you understood this part, and from other lectures, in the future lectures, we'll check all the types which are involved in definite integration. Till then, take care. Bye bye.